Hello, boys and girls. Welcome back to another edition of Think Different Television. All right. Today we're going to do distance between 2 points right here. So let's see how we do it. Let's set up our paper first. So here, distance on a coordinate plane, distance between 2 points, and write the date right here, whatever the date may be when we're doing this. Okay, so first things first. So distance on a number line. So let's just draw a number line here. And it gives the example, so we put 0 here. If you have graph paper, that's really great. You should probably have it for this lesson because it's going to benefit you. So we have -1, -2, -3, -4. So this is the example they give, -4 to 2. So this would be -3, -2, -1, 1, 2, 3, etc. So if you're from -4 to 2, so what's the distance between these two? Pause the video and copy this down if you need. It's going to help you later. So it gives you a bunch of crap. This is A, this is B. Let's say point A, point B. So it's B minus A. Absolute value. The reason why it's absolute value because absolute value turns values positive. It means the distance away from 0. The distance is always positive. So you can do all this crap if you want. You can subtract -4 minus 2. Or 2 minus -4, and then make it positive because distance is positive, or you can just count 1, 2, 3, 4, 5, 6. So the distance is 6. So between -4 and 2, distance is 6. Okay. Now, what happens if you have this now? Okay, so draw a coordinate plane like this. So now, let's look back at our problem. Oops, sorry. I meant to hit this. So, we have -2 and -1, and then 1 and 3. What's the distance between those points? So we have -2, -1, and 1 and 3. So A is -2, -1, and B is 1, 3. Okay, so let's plot these right here. So -2, -1, bam, that's A. And then B is 1, 1, 2, 3. Here's B right here. So, how do you do that? So if this is the distance between them right here. So we have a problem right here. So, what is that? Is that 1? Is that a half? Is that like 3/4? How do you count diagonally like that? Well, you can't. You can't accurately do that. But as we learned from here, you can count across horizontally, and you can count vertically very easily. So one way to solve this is through the Pythagorean theorem. Which is a squared plus b squared equals c squared, aka leg squared plus leg squared equals hypotenuse squared. So this is one way to solve it. Because all I can do is I can create a triangle like this. Or I can create a triangle like this. It doesn't matter which way. Let's do it this way. So, So now you have a right triangle, bam, right here. And so now every right triangle, you can use the Pythagorean theorem to figure out a missing side. So we're looking for C right here. We're looking for this hypotenuse, which is opposite the right angle. So I need this and this. I need the 2 legs. I can do that by counting. 1, 2, 3. Boom! And I can count up right here. So it's going to be 1, 2, 3, 4. So those are my 2 legs. So that's going to be 3 squared plus 4 squared equals C squared. Is what I want, my distance. So that's going to be 3 times 3 is 9. That's not 6. That's 3 times 3. Plus 4 times 4, which is 16, is c squared. Add them up. You get 25 equals c squared. What's the opposite of square? Yes, square root. Now, this is going to be plus or minus because what number squared is 25? That would be 5. But also -5 because -5 times -5 is also 25. But remember, we're talking about distance, so we do positive or negative for distance value. We always do the positive, so the answer is 5. So this distance is 5. Bam. So one way to do it, you saw it, Pythagorean theorem. Other way is the distance formula. Bam. So distance formula. That's going to be d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now that looks pretty complicated. You're like, what the hell is this? Where did we get this from? Well, this and this is the same thing. And so x2 minus x1, use these coordinates up here. But I don't even do that because this is the distance formula, right? Watch what I do. So distance equals. So I'm going to square root. I'm going to get 5. I'm going to get the same answer here. I'm going to get 5. So x2 minus x1, this is just the, and write this down, distance of the x values. And this is the distance of y values. Like that. So here is the x values, -2 and 1. So how far is -2 and 1 away from each other? That's going to be 1, 2, 3, right? So this right here is going to be 3. So I don't even have to subtract these. I just know the distance is 3. Now what if I said -3? Well, that doesn't matter because anything squared is a positive number. So that's going to be 3 squared plus, now this is the distance of the y values. So the y values, -1 and 3. How far are -1 and 3 apart? Yeah, 1, 2, 3, 4. There you go. And look, it looks the same thing as what we just did, right? Square root of 9 plus 16, which is the square root of 25, which is, bam, 5. So same thing. It works either way, whatever you need. So generally, if I have a picture, I'm going with this. If I don't have a picture, if I don't have graph paper, this works every time. Let's see another one, shall we? Yeah. All right, doing good. We don't have to do this. We don't count a number line. That's easy. All right, let's try 10 right here. So we have R. I'm writing in my notebook right now, which is -2, 3. And I have S, which is 3, 15. Cool. All right, let's go to our notebook and see if we can get it. I know it says Pythagorean theorem, but we're going to do it both ways. Both ways. I know I have to go to 15 on the Y, so I got to make a lot of room. So I'll make my x-axis way down here. So -2, 3. 1, 2, 3. Bam. So this is R. And then S is 3. 1, 2, 3. 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Whoop! All the way up here, 15. This is S. And this Y value up. So I need this distance here. Oops, sorry. Wait it straight. That distance. Okay. So first thing, Pythagorean theorem. That's what we're going to do. So this is C. This is my hypotenuse. So I'm going to go over to here. And then you can write a dotted line if you want. Sometimes they have dotted lines. There's not a real line. We're just making up imaginary lines right there. Okay, so there's my right angle. So this distance is 1, 2, 3, 4, 5. So Pythagorean theorem. So remember, that's a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Always go back to your notes. That's why you got it. So this is 5. And this is going to be 1, 2, 3. Take your time. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bam. So leg squared plus leg squared equals hypotenuse or distance squared. 5 squared, 5 times 5, 25. 12 squared is 144. C squared is what I'm looking for. 25 plus 144 is 169. So there's, what number squared is 169? There's two answers, right? Because it's a positive and negative answer. See, you could square root and put that in your calculator. You should get positive or negative 13. But you know that the answer is just 13 because distance is positive. So the answer here is 13, Pythagorean theorem way. Bam, got it. Okay, now let's do the distance formula way. Okay, no problem. So, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All that. Sorry, I'm running out of room. No problem. Distance equals. Okay, I'm not even looking at my picture now. I'm just going to look here. Look here. Pretend I don't even have a picture. So the distance of the x's, that's what this means, right? -2 and 3. Those are the x values. So what's the distance between -2 and 3? Yeah, 5. And square it. So it's essentially the same thing we're doing. So it's easy without a picture. So y2 minus y1. So 3 and 15. How far are they apart on a number line? 3 and 15. Yeah, they're 12 spaces apart. And we just did this. D equals 25 plus 144 is the square root of 169, which is ding, 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 13. There you go. So same answer. One with the picture, one without. Cool. All right, nice job. Keep crushing. Knock out the next ones. Good work, everybody.